Space is vast. It holds countless wonders. The universe stretches out in all directions, an endless expanse filled with stars, planets, and galaxies. Each point of light in the night sky represents a distant world, a potential mystery waiting to be uncovered. One of these wonders is how time behaves. It's not constant, it's relative. When astronauts venture into space, they experience time differently than we do on Earth. This phenomenon is not just a theoretical concept but a reality that has been observed and measured. This means time can speed up or slow down. Imagine that. In the vastness of space, an astronaut's clock ticks at a different rate compared to a clock on Earth. This difference, though often minuscule, can have significant implications for space travel and our understanding of the universe. This mind-bending concept is called time dilation. It challenges our everyday experiences and perceptions of time. In the microgravity environment of a space station, time dilation becomes more than just a concept. It becomes a lived experience for astronauts. It's a consequence of Einstein's theory of relativity. Albert Einstein revolutionized our understanding of space and time with his groundbreaking theories. His equations showed that time is intertwined with the fabric of space itself, bending and stretching under the influence of gravity and speed. Time dilation tells us that time is not absolute. It varies depending on where you are and how fast you're moving. This revelation has profound implications for everything from GPS satellites to the future of interstellar travel. It's affected by gravity and speed. The stronger the gravitational field, the slower time moves. Similarly, the faster you travel, the more pronounced the effects of time dilation become. This interplay between gravity, speed, and time continues to be a source of fascination and study for scientists around the world. Einstein showed us that time is like a river. It flows at different speeds depending on where you are. Near massive objects, time flows slower. This is due to the strong gravitational pull. Think of it like this: gravity warps the fabric of space-time. This warping affects the flow of time. The stronger the gravity, the slower time moves. Earth has gravity, it's what keeps us grounded. But Earth's gravity is weak compared to a black hole. A black hole's gravity is so strong that time almost stops. So where does this leave astronauts? They experience time differently than us on Earth. This is because they are further away from Earth's gravity. The ISS, a time machine in orbit, the International Space Station or ISS orbits Earth at an average altitude of about 400 kilometers or 248 miles. Up there, it's far enough to experience slightly less gravity than we do on the surface of our planet. This reduced gravity means that time moves a tiny bit faster for astronauts on the ISS compared to those of us on Earth. But don't expect astronauts to return years younger. The difference in time is incredibly small. However, this tiny difference is measurable with precise instruments. This phenomenon is a fascinating demonstration of Einstein's theory of relativity, which tells us that time is not a constant and can be affected by speed and gravity. The ISS travels at a speed of about 28,000 kilometers per hour, or 17,500 miles per hour, which also contributes to this time dilation effect. This means that while the difference is minuscule, astronauts on the ISS are technically living in the future compared to us on Earth. The concept of time dilation is not just a theoretical idea, but a real-world phenomenon that we can observe and measure. So, in a way, the ISS is like a time machine, giving us a glimpse into the complexities of time and space. It's a reminder of how much we still have to learn about the universe and our place within it. The International Space Station continues to be a hub of scientific discovery, pushing the boundaries of our understanding every day. And who knows what other secrets of time and space it might help us uncover in the future. Astronauts, time travelers of our time. Astronauts, the brave explorers of the final frontier, are often considered modern-day time travelers. Their journeys into the vast expanse of space bring them face-to-face with phenomena that challenge our understanding of time itself. The effects of time dilation are real. When astronauts travel at high speeds or stay in space for extended periods, time moves differently for them compared to those of us on Earth. This isn't just science fiction, it's a proven aspect of Einstein's theory of relativity. They must be considered for space travel, especially long missions. As we plan for future missions to Mars and beyond, understanding time dilation becomes crucial. It affects not only the astronauts' perception of time, but also their physical and mental well-being. Imagine traveling to distant stars. The farther we venture into space, the more pronounced the effects of time dilation become. A journey that seems like a few years to the astronauts could be decades or even centuries for those left behind on Earth. Time dilation would be significant. This means that astronauts could return to a world that has aged far more than they have. It's a fascinating and somewhat eerie concept that underscores the complexities of space travel. The universe is full of mysteries. From black holes to dark matter, there are countless phenomena that we have yet to fully understand. Time dilation is just one piece of this cosmic puzzle. Time dilation is just one of them. It serves as a reminder of how interconnected space and time truly are. As we push the boundaries of human exploration, we continue to uncover the intricate tapestry of the universe. It reminds us that space and time are interconnected. Every mission, every experiment conducted in space, brings us closer to understanding the fundamental nature of our reality. The more we learn, the more we realize how much there is still to discover. As we explore the cosmos, we continue to learn and be amazed. Each discovery, each new piece of knowledge adds to our collective understanding and fuels our curiosity. The journey of space exploration is not just about reaching new destinations, it's about expanding the horizons of human knowledge and imagination.